Welcome scholars to your Module 4 Excel Report video. We're just going to go ahead and jump right in, starting with number 1. Make sure you put your last name on your Excel report, please. And also make sure you name your file. If this is different than what it says to name it on the cover, I'm sorry, but just make sure you name your file and put it into somewhere. Mine's already saved. This is a fresh one. I guess I can save it as video and I keep mine, and actually I'll just put it all right in here where it's supposed to go instead of doing it again later. All right, so now for number 1, I start off reading the question. You may have read it. You can pause the video and read it. Many of you will not read it, which is fine. I suppose we'll talk about it here. So we took a survey to find out how many people wanted to stay, who were happy to stay where they lived, or who wanted to move. They preferred to move out of the country. So it says that we had 29 people. For every 29 people who were happy, we had 71 who wanted to move to another country. And then it says something about a different part of this population or this sample. It says that 24 out of 71 say that they wanted to move to the U.S. So 24 out of 71 to the U.S. 7 out of 71 wanted to go to Canada, and 7 out of 71 wanted to go to the UK. And talks about some other things, based the numbers. If a random sample of 1 million people was chosen from around the globe, how many would like to move to each listed country? All right, so it says that this was a global survey. We have, for every 29 people who were happy, 71 were not happy. So let's look at let's see how that would look over here in Excel. I'm going to go ahead and start by creating a chart. I'm going to say that this is the worldwide poll from 2008 to 2010. Poll. I hope you guys caught that. All right, the worldwide 2000 poll of if people wanted to stay or move. So we have, make sure I was recording there. We have the people who want to stay and the people who want to move. Then we're going to report the number. Let's report the number and the percentage. So we want to know the number of those people, and we're also going to have a look at the percentage. And you'll see, hopefully, if you don't understand why we would want the percentage, hopefully you'll see here in just a second. All right, my percentage looks like I could stretch this just a little bit just to make it look better. All right, the people who want to stay, the people who want to move, and then what about the total? The total sample, because this is the number from the sample we took. Obviously, we did not poll every single person on the globe to see whether they wanted to stay where they live or move. We took a certain sample, and of that sample, the reduced fraction was that 29 would be happy and 71 would prefer to move. And we don't know if that's a reduced fraction or if that's the entire sample. So we have to, well, let's fill this in and then we'll talk about that. So we had 29 people wanted to stay and 71 people wanted to move. So when we talk about the total, this gives us the total of how many people we had in the entire survey. So I'm just going to go to edit and sum. If your Excel is stretched out far enough, your sum button will be up here at the top. But if your Excel is not stretched out far enough, and mine's not because I want to be able to look at my exam Excel document over here. In this case, I had to go to edit and find it. So I have to go back over here and select these two. And I'm going to get the sum of them, and it is 100. And you'll find for the QL textbook with Dave Sebecki where these problems came from, he uses 100 as the denominator for all of these problems, which was very nice of him because what does that tell us about the percentage instantly? When it's over 100, it's going to automatically be 29%, but let's double check it. We can put an equal sign, and then for the percentage, we'll want this number divided by the total. And we get 0.29, and we'll change that in a second. And then for this one, let's see if this will. Now let's see why this happened. First, I'm going to show you guys right here. Do you see the proximity? This chose the one above divided by the one 2 places up, 1 and 2 places to the right, like a knight moves in chess. So when I drug it over to apply that same formula here, to apply the same formula here, you see how it grabbed those two values and moved it over and grabbed this empty place, and we cannot divide by 0, which is what it says here. So what I can do, if I want to lock this cell, and I understand that you guys can just type in 100 and that there are other ways you can just choose equal and do it again, but I'm teaching you how to use these tools on simple problems so you can use them on harder problems more naturally. All right, now I locked that cell in, so now when I drag this over, it will still keep the proximity of the one above, but then it didn't move the cell that was locked with the dollar signs. Cool, huh? And hopefully you know that from previous videos we've done together. All right, so we have our percentage, and we can even add these percentages up. Well, I can just drag this down. And now I can change these 3 cells. Go here to number and just click my percentage. How about that? All right, another thing I like to do is once I highlight that, I'm gonna put a border around this, but I also want to put a border on these two. I don't want to do this whole border just because I don't like how it looks, but I want to border this and these two on the left. So I'm going to press my control button on my keyboard and it will let me highlight multiple sections. Now I am going to add a border, all borders. And mine's already thick. If yours isn't thick how you like it, then when you go to all borders, you go to line style and you can make yours thicker. Yours is by default, it's the one up here at the top, but I chose the one at the bottom. And once you choose it, you're going to get this little ink pen. And the ink pen will let you draw in lines. But what I do is you just hit escape. And then you choose your all borders again, and it will give it to you. Another thing I like to do, you see how my total sample is too far out? I like to right click, format, and wrap. I like it when my text is wrapped. And it just does that. And these guys up here can be merged because this is the whole entire poll. See how that just makes sense? No, it made it wide, so I have to unwiden it if I want it. All right, so that looks pretty good. Now, and there are more things. I could center these. I can, add some colors. I expect you guys, the rubric has something over here that says originality, doesn't it? Yes. You see right here on your rubric, organization, neatness, and originality. Right here. So I do expect to see you guys put some of your own colors and, do some original work on your Excels, okay? But I'm not going to take the time to do all that. I know I always say that and then I end up doing it. But okay, let's move along. Now I am going to grab this information. Let's see, what do we have here? I'm going to insert a pie chart. And hopefully you can see that this pie chart is not working because we used our total over here. And that's why things got messy. So we need to delete that. And I just want these two sections. And really, I just want that. I just want the ones who stayed and the one who moved. And I'm going to put that into a pie chart. I can do other types of charts, but I'm going to use a pie chart. What do you guys like? That one looks a little deceiving. It makes it look like even more than the 71%, doesn't it? Some different ways we can depict that. All right, let's just do a regular pie chart here. You guys can choose whatever you want to. You have all these neat styles and different things you can do. You can change the colors, you know? All right, but I'm just leaving mine like this. And your default might be something completely different. All right, so for my chart title, I'm actually going to choose this cell, make it easy, Control C, come back over here, Control Victor, Control V. I also want to add some labels. So let's put some data labels. We have some different ways we can put the labels in. I just like the call outs. I always think they look cool. I even just like to kind of make the, I don't know, what do you call that? The stem a little longer. All right. And now we can see that of the people who want to move, of the whole entire sample, 71% of the people want to move. All right, so let's look at the next part of what we have going on here. Of all the people who want to move, we have some that want to move to the US, some want to move to Canada, and some want to move to the United Kingdom, to the UK. So let's see what a chart like that looks like. All right, let's go ahead and start with our United States, Canada, and UK. All right, and I'm going to, I guess I could do either pull this out or I can format it to wrap. I'm just going to leave it like that since I already did it. And then we want our percents of each of these. And what are those wanting to move? Well, why do we want those wanting to move? Let's talk about that. All right, I am going to format this cell to wrap. I don't have it selected correctly because I formatted the cell while I'm in a position to write or type into it. I do not get all my options. To get your options, you have to have just one single click or even only a right click on the cell and go to format, and then you get your alignment and all these other options. So I'm going to wrap text. All right, I'm looking for percents, and how do I find a percent? Well, a percent is some number out of a whole, which in this case is, put an equal sign because I want Excel to do my math for me, 24 out of 71, enter. this one is going to be 7 out of 71. Enter. And this one I think is the same, so I'm just going to do that. All right, now I want to change these to %. Very good. All right, and then we need another piece of information. If these are the percentages of people who want to move to each of the countries out of this 71% who wants to even move, then if I want to find the number out of 1 million, then let's have a look at what we have to do here. What do we want to do? Wrap this? All right, the number out of 1 million. Well, we have, first of all, 71%. So we have 71% of, well, we need our times, of 34% times our 1 million. Hold on, let me stop for a second and have a look at this. I got distracted. Okay, I'm back. All right, we were doing 34% times 71%, but I was doing decimal, and what I had wanted to do was I have 34% of the people who want to move. So that's 34% of this 71, of this orange section, you see? That's why a lot of people get this one wrong on the homework, because they do 34% of 1 million. And you guys are doing part of the problem correctly, but you're forgetting that out of that 1 million people, we can only look at 71% of that 1 million people. So what I have is 34% of 71% of 1 million. Hopefully you guys understand that. So I have 34% of, and most of us remember that multiplication and the word of go hand in hand in math. 34% of the 71% of the 1 million. 4, 5, 6. I just do 1 and then count 6 with my zeros. All right, and then we get 240,000. And our next one, I think I can I just, can I just drag this down? You guys tell me. Is that going to work? Why didn't it work? Hopefully you know. It didn't work because, you see, it changed the proximity. So what did I need to do? Lock my cell. I highly encourage you guys, when I look at your formulas, I like to look and see some dollar signs around to see that you're learning to use the lock cell features. It will help you later. All right, so now what about this one? Would it make sense to do a pie chart for this problem? And why wouldn't it? I guess I just gave away the answer. It would not make sense to use a pie chart for this data because it doesn't equal 100%, you see? A pie chart consists of 100% of 360 degrees of a circle, and if the percentages don't add up to 100%, we can't use a pie chart. So a better chart for this one would be let's just see how this is going to look. I think we're going to need to just choose 2 columns, but let's see, insert. All right, so we have a problem here. I'm going to let you take a second to look, see if you can identify our problem. While you're looking at that, I'm going to be changing my chart titles. And I guess I'll also add some axes titles. Add a title to each axis, or add axes titles. All right, so over on this one, I have number of people. And down here, I have the top 3 choices. Can't see if sure I made a typo there. I felt it on my typing. Top 3 choices. All right, that looks pretty good. I like how my graph looks here. And then, of course, I would want to add a text box over here. I actually have already done all of this, so I'm just going to grab this and insert it. Please do not forget your 5 sentences, okay? Don't forget your 5 sentences about your problem, because that's worth 60 points of the whole test, and some folks are leaving that off. So watch that. Guys, that was number 1. I think that's it for number 1. A nice graph and chart. Make sure you explain to us why we had to take the 71% of the million before we can take the 34%. See if you can find a nice way to say that to us and write about it. Looking forward to seeing that. See you on number 2. All right, you guys ready for number 2? Number 2 gives us a linear equation and tells us to write a real-life scenario for this function. Recall that in y equals mx plus b, m represents the constant rate of change, and b represents the starting place. All right, so we're going to actually use this function. You have that g of x, which is g of x is a generic notation for functions, a generic function notation, equals 3/4 x plus 2. So your job is to create a table showing the input and the output for your scenario, and then create a graph and label all parts to correlate with your story. Discuss the relevance of the intercepts of your story, and use one other point on the graph within your story. Mention the rate of change and the relationship between the input and the output. Write a 5-sentence summary of the scenario and the process used to complete the question, and discuss your findings. All right, some of you are going to be super overwhelmed by this, because here you have some function with a fraction in it, and I know that's scary in itself. And now you have to actually create a story, and then it tells you to write all this stuff in 5 sentences. I'm going to show you guys how easy that is. Please don't use my exact story, and try to change it enough to be personal for yourselves, okay? All right, number 2. For number 2, I am going to, my story that I made up says that it's going to cost us, I'm going to do the cost of riding in a rickshaw. If you want to hire a rickshaw. And the reason I chose a rickshaw is because I recently said I wanted to do something, but I did not know what it was called. So I Googled as much as I could about it, and found out that what I wanted to do was called being a rickshaw driver. So you guys can look that up, okay? All right, so my rickshaw is going to cost, it's a very economical cost. My rickshaw is going to cost, the cost of a rickshaw in dollars per mile. And here I am going to have my miles and my cost. I'm going to merge those 2 cells, and then I'm also going to format them to wrap the text, make it look a little nice. And why not even give it a little color? All right, so here I want my miles to, and I just got distracted because I was thinking up here, of course I would have liked to see all of this with borders around it and some colors and, things just to make it look nice. Please take pride in your work, folks. Please do not feel that you're limited to my guidance here. This is simply a guide. This is not the maximum expectation, what I do in these videos. So please keep that in mind as I'm just trying to work through these for you to have something to go by. All right, so miles. Would I travel a negative number of miles? Never. You don't believe me? Watch Ferris Bueller's Day Off and see what happens when they try to get the miles off the speedometer in the car there in the garage. All right, so here I have my miles are at 0, and I'm going to go ahead and count by ones. Of course, I could count my rickshaw ride in fractions of miles if I wanted to, but I'm just going to go ahead and count it by integers. And then what is my cost going to be? Well, it has to be this equation because that's my function g of x. And, I could have, actually, I'm going to go ahead and do that. Function for okay. A lot of typos. I know, and I know I'm not even catching them all. I'm going to format this cell to wrap my text. All right. Any more typos? We'll just move past those. So the formula for this, and I'm going to change it over here. This says g of x. Remember, I used the word generic function notation. Well, now I have actual cost per mile, don't I? Or you might more commonly see cost per distance. You can make that decision. Do you want it to be cost per distance or cost per mile? And yours will hopefully not be cost per mile. Hopefully we'll have a completely unique story. This can be for a recipe. Please think of something unique for your linear. Look at Google different stories for linear equations. All right, mine's going to be the cost per mile is 3/4. And I always like to put my fractions in parentheses. You don't always need to, but it's good practice and it keeps your work organized and easy to see. Easy to identify different parts of your functions especially. And now instead of x, my new variable is m for miles plus 2. And my scenario is going to be, now that I have this typed in, I can just use this. I can copy and paste. But where it says M here, I'm actually going to use this All right, everybody, number 3 should be familiar to you. We did this in our course overview. Well, I was trying to get that extra line off there, but I'm making a mess out of things. So let's just move on. All right, number 3. We did in our very first Excel, and it is the tennis shoe problem, tennis shoe sales, if you remember. So for our, we have a company that produces discount sneakers, and the function that models their profit depending on the number of sneakers that they sell is P of X equals this value here. So here I'm going to go ahead and just explain that this is the formula to model the number of sneakers. So here we have, do I get a, no, just wondering if I had the same feature, my dictate feature on my Word documents is one of my favorite things to use. I didn't remember if Excel had it or not. So here we have the formula to model all right. And then you probably already know I am going to format this cell and wrap the text. And then what is our equation going to be? Well, we have f of x or g of x are generic functions. This is p of x, and you could do p of s if you wanted to for sneaker sales. You can just stick with x. All right, so we have p of x equals 4x squared, and you can do 4x squared like this, or if you're good at finding stuff, you can go to insert symbols. See, I cannot tell you why. Let's see. If I just click that cell, if I'm actually in a position to text into this cell, I cannot access this right here where it says equation. You see how it's ghosted out? So if I'm only clicked in a cell one time, I can access that. So I'm going to see if I can cut and paste. So I'm just going to, here there are all kinds of things. I'm just going to click this. Well, I was actually going to cut and paste this. I guess I still can. All right, just go with it here. I have P of X. This is how I do it on my own. I don't know if this is going to confuse you guys or not. So then I have 4. Sometimes you have to be careful the way you change their automatic things that will delete and stuff, do different things. So here I have 4x squared minus 32x minus 240. All right. Now I am just going to get rid of what's in this cell, and I'm just going to scoot that right over there. I probably shouldn't have really done all that with you guys, because you can just do the Shift 6 key and just type in P of X equals 4x squared, and that'll be perfectly fine. I just wanted to show you guys how to do the other. Okay, so moving right along here, we're going to create a chart that has the number of sneakers sold and the profit which is P of X. Are sneakers sold? Well, are we going to sell any negative number of sneakers? Do we sell negative one pair of sneakers? No. So the least amount we can start with is 0. And we're not going to sell any fractions of sneakers, so I'm just going to go to integers only. I guess I'll take it to 24. I'm not really sure why whatever happened just happened. I am going to I'm going to pause this for a second, see if I can figure this out. All right, so it was because this, I believe that this was overlapping into the next cell, so I just expanded it. You may have not even had that occur in your situation. All right, so now I have 0, 1. I'm going to take this down to 24. Just keeps hitting that same spot. Hey, I already have this typed, so I can actually use this, I think. I've actually never used something from inserting it the way that I did, so I'm trying something brand new here. All right, and look how it changed it. You see that? I had it in there as the function x squared, and it actually put the shift 6 caret key in there, and that's what we call it, a caret key. All right, so wherever I have x, I'm going to now have times this value, and again times this value, because that's my x. Enter. And hopefully you can see if I sell 0 pair of sneakers, I am at negative 240, and it does not say that in the story, but it's something that we're going to discuss, is that the initial investment was $240. All right, so I'm going to double click, and voila, I have this nice set of data. I'm going to select this data and insert a scatter plot with smooth lines. And I can choose to have markers on my lines if I want. I'll go ahead and put the markers. A couple other things I want to do. Of course, I want to add some labels, axes labels. And we have pairs of sneakers sold. And then over here we have the profit. And you guys should make these larger. Make your font bigger, make it look nice. What I'm doing here is the absolute minimum to give you a guide, not to be the full final finished product. So please be careful of that. Change your title, make it all look good. Your axes, I'm going to change mine to have a major to count by units of 1 rather than 5. And what about these? This is rising by 200. I'm just going to go ahead and change it to 100. Looks kind of busy, so I'm going to just give it a little bit more height there. All right, let's look at a few things. We've done all of this in part 1. A lot of stuff it says on this table over here. Create a graph, label all the parts of the graph according to the story on the table, and graph highlight the initial investment of the sneakers. The initial investment was right here at 0 sneakers. So I'm going to highlight that. How do I highlight it on my graph? I'm going to insert a shape, which is going to be here. If your Excel is if you make your Excel big, you can find it real easily. But if you don't, then you go to illustrations, shapes, and insert a little, well, I chose that circle. I don't want to choose the circle. I want to choose something better. I didn't realize it till after I made the last video for module 1. But look, we have all these little cool things. How about a star? All right, so here I have my initial investment, and I'm going to just fill this shape with the same color as where I marked it up there. All right, and then what else do we have? Initial investment, the worst that they did. Well, the bottom dollar. What is the bottom dollar? It looks like at about 4 pair of shoes. It looks like we had our bottom dollar right at about 4 pair of shoes. So what does that look like on our graph? Do you see on the graph how at this point down here we were at negative 304, but on either side we're at negative 300. So this was a bottom dollar, and if it's not exact, it's pretty close to it. So I'm actually just going to copy and paste my star, and then I'm just going to change the inside color of that. All right, and then you guys go on and keep going. It wants you to talk about where the company broke even. They break even right here when it hits $0. That's when they're no longer in the hole and they're not making any money. They just broke even right here. You're going to highlight that point, and we look how Excel gives us that 1320. And look, right here, I guess I should talk to you about this. At 1320, clearly they did not exactly break even because that's not at 0 profit. So it's somewhere right between 12 and 13. And, you know, I'll even show you guys. You can choose. I just selected that and pressed Control C. Some of you are going to like this and some of you are going to be confused by it. I understand. Where should I do this? I'm going to move this over. I'm going to show this to you guys right here. I just chose those two values at 12 and 13. And the reason I chose those two values is because somewhere between those two is where I hit 0. Do you see that? Somewhere right between there is where I hit $0. But you see, the thing is, we don't sell fractions of shoes. So it doesn't make sense to say we sold 12.5 pair of shoes. We would just say we sold 13 pair of shoes. But if I really wanted to find that 0, then I would just select this one and I would make it like 12.1. And then I would look at somewhere between 12.7 and 12.8 is when it happened. Do you guys see that? Right here between 12.7 and 12.8 is right where I hit $0. See how precise we can get? And I can even pull these two apart and get even more decimal values there. I just wanted to show that to you guys. All right, let's get back to where we were, which I was just about done because I feel like you guys should be able to finish this out on your own. On the graph, highlight where they make a $500 profit. So you're going to find up here where they hit $500 and you're going to put another star, and you're also going to mark that over here on your chart. And again, you don't hit exactly on. We don't sell fractions of shoes. So you actually have to sell the 19 pair of shoes in order to make $500 profit. All right, and then you guys are going to, and this is just the one that I created. I didn't actually redo this problem. I just cut and pasted off that original one that I created for Module 1. So on the Module 1 exam, I actually go through this whole problem in more detail. Here are my 5 sentences. So you guys can look at all of that and finish that one up. And it looks like we're already ready to move on to number 4. Yay. All right, you guys ready for number 4? Number 4 is talking about projectile motion, which is going to give us the same shape, a parabola, of a graph that we had in our number 3 in our cost according to the number of sales. For this one, we're going to talk about a function that gives us the height depending on the amount of time. And I'm looking at the height of a baseball, which is pitched by a major league pitcher. And major league pitchers can throw a ball at 89 miles per hour, which is 131 feet per second. When we look at our function here, we're talking about the height according to the time. We have the function of negative 16 times time squared plus my initial velocity times time plus the initial height. Anytime you see this sub-zero on a variable, that means the starting point, the initial point. So we here have our initial velocity at 131 feet per second. Nice of your authors, your textbook authors, to convert this for you. And what about our initial height? Because I need variables to plug in here. The height, h of t, is my output, and the amount of time is my input, which is going to give us a chart very much like we had in number 3. As a matter of fact, we'll even just cut and paste that when we get ready to do that. So these guys, what are these guys? Throw a ball straight up. Looks like we have some typo there. I'll deal with that later. Let's say the pitcher is 6 feet tall and he releases the ball from a point a foot above his head. So that's giving us our initial height, but it's making us think a little. The author didn't make us convert 89 miles per hour to feet per second, but he did make us do a little bit of math right here. So no complaining about that. So the initial height looks like it's going to be 7. So I'm going to go ahead and plug my formula in. But before I do that, I'm going to prepare my chart. I know that I could totally just type all this in, but I'm just going to cut and paste. This is number 4. All right, I'm going to pause the video for a second. Okay, so for whatever reason, mine was not pasting. If you have that problem, just keep trying it and it will eventually work. I didn't do anything special, it just worked. All right, so I'm going to see how I have these colored, and I'm clearly not going to have all the same intercepts and things, so I'm going to change all that to white, which gives me that blank look. So, and also you guys, here I'm putting borders around this. I would have liked to see borders up here on this one too, on number 3, and some colors where your labels were and things, okay? Again, I keep saying it, but please, you are not limited to what I'm doing here. All right, so a formula to model the what? The height in feet depending on the time in seconds. All right, and you might choose to say the height of a baseball thrown by a major league pitcher. You know, you can, whatever you decide to say. All right, so now my function is a little different. I have my force of gravity, which is what the negative 16, when we have feet per second, our force of gravity is negative 16 feet per second. If we're talking about meters, it's usually, I think it's like negative 4.9 meters per second. All right, so we have negative 16, and then, not that it matters, but we're using t instead of x, plus, and you don't need to see what I'm typing in here. If you guys are saying I can't see, it's too small, good, because I want you to find the information in your problem and type it in. All right, now I have my initial velocity. I did highlight that in green. It was 131 times t. And then our initial height. in this case was 7. All right, and it looks like in what I've typed over here, my equation went a little far out, so I'm going to just stretch my column a little. All right, and then I still have my P of X, so I'm actually going to do H. Do we use a capital, no, a lowercase? H of T. Very nice. All right. So we have our equation in there, and since I was going to have to type this out anyway. So I can just copy it now and put it right here into this. And then everywhere I have a T, you see here I have my T as I'm going to have to go back and change. My T is not squared in that equation I wrote over there, but I've already got this one going. So I'm going to do times T squared plus 131 times T plus 7. All right, you guys ready for number 5? Number 5 says that we have some crazy math professor that retires to the Bahamas, or here Costa Rica, and this crazy math professor has decided to open a resort and offer 3 crazy different pricing options to his patrons. So here for the first option, he charges $25 for the first day, and then it decreases by $25 every day that you stay. The second option is that it's $300 for the first day, and then each day after, you subtract 10 times the square of the number of days you've been there from the previous day's cost. And then for option 3, we have $500 for the first day, $250 the second day, and then in general it just keeps decreasing in half as each day goes on. We're going to create a table of the number of days and the costs for each of these 3 options. We're going to create a graph from each of our charts and connect the graphs with smooth lines and name the types of decline represented by each. So we're going to be talking about whether or not it's a linear decline, a quadratic, or an exponential. And then we're going to label our axes of each graph to correlate with our story. And then write a 5-sentence summary discussing the option costs and the least and how many days you can stay and which option allows you to stay the longest and how long you can stay there. So we'll see all that as it comes along here. All right, so for number 5, I already went in and typed this just to shorten the length of the video. So I have just summarized the options. I have created 4 columns, one for the number of days, and then for option 1, $200 first day, decrease 25 a day. Option 2, and it's complicated wording, which we'll look at in better detail as we move along. And then the last one, which is easy, 500 a day, and then it goes down by half. All right, so we're only going to count our days in integers. And we're not going to stay 0 days. So we're actually going to start at 1 day and not 0. Just get some values going down there. I don't know how many values I'm going to need, so I just choose however many. All right, this is the fun part. We actually are responsible to write the functions for these decreases for a linear, a quadratic, and an exponential decline. And in this case, we're going to put an equal sign, and let's just read the problem. We have $200 to start minus $25 for every day that we've been there. So minus $25 times, how many days have we been there? Well, we've been there, this is day 1, minus 1 day. Because you see, we actually have not stayed there 1 day yet. We just got there. So really this is kind of like our 0th day. But a 0th is not a word. So in this case, we have that day minus 1 tells us how many days, how much our charge is going to be. And in this case, our charge, why did this happen? Let's look at this. Shouldn't my very first day be $200? It says it's $200 for day 1. So the problem here is my order of operations did 25 times 1 minus 1. So I needed to tell it to consider my number of days minus 1 as the first thing to do. Remember your parentheses, PEMDAS? For those of you who remember PEMDAS, if you don't know what that is, just know you need to put these in parentheses to save your order of operations correctly. All right, now I'm going to apply that formula to every day after. So you see that on the 9th day, I hit $0. And it says something in this problem somewhere up in here that once you reach $0, you have to leave. So that means that all of these values are irrelevant. So I'm just going to clear those contents. But I'm still going to keep these numbers because I don't know what's going to happen with these other options. Maybe I can stay longer on option 2. And it actually says In your 5-sentence summary, discuss which options cost the least and how many days you can stay, and in which options allow you to stay the longest. So you do need to look at all this information, and when you do this homework problem number 28, you will see that you have to answer all these questions. So for option 2, this is the weird one that really throws students off. Here I have my equal sign. It's 300 my first day, so I start with that. Subtract 10 times the square of the number of days. So that's 10 times the square. That's this number. The number of days I've stayed there. Do you see what I've done wrong here? It's not that number. It's the number of days I've stayed. But I have not yet stayed one day. So it's actually that number minus 1. I don't know if you guys are catching that, why I have to do the minus 1, but I haven't actually stayed there a day. And then on the second day, I will have stayed there one day. So that's going to be 2 minus 1. See if you can make that connection. Think about that. All right, so here I have, let's see, 300 minus 10 times the square of the number of those days. So that's the square, that number of days I've stayed squared, from the previous day's cost. So what does that mean? Let's have a look. All right, so the first day is $300, but what about the second day? Can I do that to the second day? Well, I can, because on the second day it was $300. So this 300 still makes sense. But what's going to happen on the third day? On the third day, I still did 300 minus the square of how many days I've stayed there, but I needed to do 290 minus that. So how I render that, do you see why I had to do 290? Because it's 10 times the square of the number of days you've been there from the previous day's cost. So when I get down to the third day, this should be 290. And I'm certainly not going to go through and keep changing all those values. So on this right here where I have this 300, I'm actually going to grab this value. Now you see it did that for me. So it doesn't look like I get to stay here very long. At this rate, I need to get out after, 5 days? Because remember, you have to leave when it hits 0. And you must leave when it reaches 0. You see right there? That's where it says that. All right, option 3. We start off at I need my equal sign. We start out at $500 for the first day. And then it decreases by half each day. So that's going to be $500 for the first day. And then the second day is going to be 500 divided by 2, half of. And you can either say divided by 2 or you can say times 0.5. If you guys realize that those are the same things, half of. So either way, you'll get the same answers there. So here I am, I didn't need to use my days because it's just half of the previous day. It looks like these numbers are going to keep going. Does anybody know how many fractions there are between the numbers 1 and 2? How many fractions are there between the numbers 1 and 2? That's a good question. You can Google that. But here, what's happening? Well, we're taking half of the day before. So when are we going to be able to stop taking half? When will we not be able to take half anymore? Um, let's look at this. When would it ever stop? It just keeps going. What does this E mean? E to the -5 means that I would move my decimal 5 more places to the left. And if I expanded this, well, I can expand it, and then I can do other things like move my decimal. What would I do with this decimal? I'm doing things I don't want to spend our time doing. If I right click to format, I go to number. It says how many decimal places. And that's still not what I'm looking for. Can we write a whole number there? Yeah. You see that number? Now I can increase my decimal places. That E just meant E to the -10. It's scientific notation. You may have seen it might be written like 2.9 to the times 10 to the power of -5. Anyway, it's beyond the scope of this particular lesson, this problem. So I'm going to undo all this, but it was fun to discuss, wasn't it? All right, I guess I should pause the video to do this. Hold on. Okay, now that we got that all cleaned up, and of course, hopefully you guys know I want to see stuff that looks like this. I want to see this stuff bordered. I want to see my titles colored in, just try to make stuff look nice, whatever you do. All right, so now I am going to create some graphs. I'm going to start with option 1. And if you only used this much data, just this little bit of data right here, let's just try this. I didn't actually do this on the one I did. I just thought of it right now. Cool. I'm just going to leave this sitting down here for a minute, okay? What I did on mine, we'll come back and look at these different shapes, okay? But let's go ahead and create our individuals first, because you can't really see it that good on that one, what you're about to see. So my first graph is going to be the number of days and option 1. I'm going to insert a nice scatter plot with smooth lines. I can choose to do it with markers or without. I guess I'll just do without for now. And of course, I'm going to mark these with axes titles, number of days, and costs. All of that needs to be labeled, folks. For option 2, I am going to choose my number of days. You're going to hold your control button, because for option 1, I could select it all together. Option 2, though, is not the same. So I'm going to select my number of days, hold the control key on my keyboard, and then select option 2 and insert a nice graph with smooth lines. And again, folks, it's up to you. Do you want markers on that? You decide. Make sure you label all of your charts, okay? Option 3, again, I'm going to select this data, hold down my control on my keyboard, and select the other set of data, and insert a graph with smooth lines. And yours doesn't have to go all the way out that far. That's such a small amount of money. I'm actually, do I really want to go that far? I don't think so. What would make the most sense? And I use that word in with a pun intended. The most sense would be, it looks like right about here. I'm going to go ahead and highlight that cell. And what's my pun? Because, well, I guess actually I could even go to this cell, can't I? Because if I were talking about money here, this is what 0.015, so that could be like 2 cents. And right here would be 0.007, so that would be like 1 cent if I round it up. So I'm still paying 1 cent here. Once I get down to day 18, I don't have any money in America that allows me to pay less than 1 cent that I know of. Maybe what are those digital coins called? Internet coins. Anyway, I can't remember the name of them, but maybe they go less than a penny. I don't know, but it looks like really 17 days, but I could just say, okay, look, since I can't pay by day because I can't pay less than a penny, I could just let all my days add up until I owe you a penny. So truthfully, he doesn't need to leave here until we cannot cut any of these in half anymore, which brings us back to my question, how many fractions are there between two integers? And that's interesting. Okay, so we wanted to, I'm just going to select this. Of course, it can keep going on. And when will it actually touch 0? I just thought of so many interesting things I could show you guys, but we'll just keep moving on here. So holding my control key down, I can select both of those columns independently, and I'm going to insert a smooth line scatter plot. And the interesting thing I was just thinking of to show you guys was the fact that if I took my vertical axes here, it's at 100, and I actually only wanted to grab, man, I can never help myself, can I? Let's say instead of counting by hundreds, I'm going to count by I'm going to count by one 1/100th. What do you think about that? 1/100th. And my maximum, I'm just going to have my maximum go just to 5. Okay? Let's just see what happens here. All right. So let's see what's all going on over here on our graph. That's certainly not what I meant to do. Well, it's difficult to see, but what I'm trying to get at, which you cannot see, I would have to make my decimal value much smaller, is the fact that this line is going to keep going and never actually hit 0. It's never going to actually hit 0 because we don't divide by 0. And I don't even remember where all these numbers were on this graph, so I'm just going to backspace. That was not really the most interesting little experiment, but my point was that this blue line down here, it looks like it might be touching the x-axis, but it never does. It actually never hits 0. There's a space in there. All right. And we'll discuss that when you talk about how long can you stay there. It says here to talk about how many days you can stay and which option allows you to stay the longest and how long can you stay. Well, that's what I was trying to get at. How long can you stay? Well, that depends on how many fractions there are between 1 and 2. How many times can you cut that in half, and half, and half, and half? Interesting thing. All right, and I'm just going to check my other one I did this morning, and I think that was all I had except this piece, and that is to write your 5 sentences. Oh, and remember this little one that we created down here gave us all the graphs, but it didn't do such a good job showing us our option 3, our exponential decrease, and our option 2, which is a quadratic decrease, and our linear decrease. Were all very vague when we put them all together, but we can definitely see them a little bit better. And as you guys label your axes and change how these are counting by twos. Make them count by ones. Give us more detail. Let your graphs show detail. This is counting by 50. What if we counted it by 10? Would that get too crowded? Yes. Can we count it by 20? 20 is not bad. All right, so give us more detail on your graphs. Label everything according to your story. Give us some color, make stuff look nice, and show off a little bit. Take pride in your work. Write your 5 sentences. Everything you need to discuss is written over here. And I'll see you on number 6. Hello everybody, we're ready for number 6, our final scenario on our Module 4 Excel report. So on number 6, we're talking about some fossilized remains that were found in 1964 that were previously thought to be Neanderthal. And I want to show you guys, when you're doing reports, I had to go and Google Neanderthal. I don't even know if I've ever actually said the word, but I just Googled pronounce Neanderthal. And you see, you can just get a pronunciation. So always make sure that you check things before you say it. So they were thought to be Neanderthal, and it surprised the scientists because they thought that they didn't know that people lived more than 8,000 years before that time. You can read this to get more clarity. And here we have that the testing of this particular fossil shows that we had 37% of the carbon-14 still in the fossil, the molecules. Unfortunately, I'm not schooled on how carbon-14 in what parts it remains, which would be a cool thing to research. And from this function that we see down here, the carbon dating formula, we're going to determine how old those remains are, which we see that they are 8,000 years older than they even realized humans had lived. So here we have that A is our initial amount of carbon, and that X is going to be the number of centuries since the carbon-14 started decaying. And you see that X is in our exponent up here. This is an exponential decay. So we're going to create a table for the number of hundreds of years. That's going to be our X, our input, and the percentage of carbon remaining, and that's going to be our output. So I am going to, I've already typed some things in here, not that. I'm just going to grab what I've already typed in, and you guys can just look at it and type it. All right, so I will go ahead and actually type the equation again, show you how I typed it here. You guys have choices. You can just type it in like this. This is how your Excel will type it. And what I did is I typed the cell, I went to insert, and then I typed in an equation. I think I chose just this A equals pi r squared, and then I just went in and actually changed the variables to be what I wanted them to be. So you guys can choose which, if you want to make it fancy or not. You're not going to get counted off if you don't make it fancy. All right, so now I have the number of years. And when we start, we don't have a negative number of years, so 0 is going to be our first number of years. I'm going to grab this equation since I've already got it typed here, and I am going to put it here. Now, let's talk about this initial starting place. It says that A sub 0, the initial amount of carbon. Well, what would you think the initial amount of carbon would be at at 0 years? Well, it would be 100%, wouldn't you say? So when we're talking here about percents, it's going to be 100%. So this is going to be 1 times 2 raised to that power. This is 100%. And I can type in the whole 100 here. It's just that I don't know. We'll see when we get to the end if it's going to give me if I'm going to be able to go back in and actually change it to percent. We'll see if I have to change that to 1. All right. So now I have my X value right here. That's what Excel didn't like, this X. So that's that number times X. And what other thing that Excel doesn't like is right here where I have this negative. It wants me to actually put a -1 and then to indicate that I'm multiplying that value times -1. And that's how it wants me to indicate a negative value. All right. So I have at the beginning, at 0 years, I have 100%. So let's see what happens. We'll just go ahead and explore for a minute. Let's just explore. Let's go ahead and see what happens at 1 there. Just drag this down, select this one, apply it to each of those. All right, now let's see what's happening here. This is giving me a percent value, and what I was talking about earlier is just if I wanted to apply percent, it's not going to work because I used that 100. If I wanted to actually apply, I've doubled up on percents now, if you can understand what I mean, and that's just because I used that 100 instead of 1 in that spot. So I can come back here because I do want to use the percent symbol. So in that case, I'm just going to use a 1 there. And 1 is 100%. You see? All right. Well, what do I want this carbon to show? I'm looking for what? 44 or what is this? 37 per. Oh, look. I'm going to highlight this right here. I'm not looking for 37%, folks. I'm looking for 37/100ths%, 0.37%. So the most I've got here is down to 78%. So I'm thinking that instead of counting by ones, maybe I'll go by 20. And remember, this is in hundreds of years, so this is actually 20 times 100. So, whoops, what are we doing here? Try to get this pattern going for 20. All right, so now at least I've gotten down to 100%. And if I want to count this in percent, the reason it only says 1, I meant to say 1%, not 100. The reason it says 1 is because my decimal isn't moved over enough. I can move this way over. And I'm going to need to, because where do I need to get down to? 0.37%. And I'm only at 0.78. So what do you guys want to do? You want to change this to 40 or 30? Definitely did not mean to do that. I have to tell Excel the pattern that I want to use there. All right. Oh, and I know what I could have done. I could have just selected those two and then double clicked. All right. Where did I get to now? Yay, I did. I got all the way down. Here it is. Can you guys see this? Right here. Where'd it go? Right here. Between, I'm struggling to say this because these are in hundreds of years. So this is going to be 45,000 years, or 450, 100. We could just say it like that. And right somewhere between 450 and 480, that's where we hit our 37, right? You see how it's somewhere right in between there? And there are some cool things I can do here. I can select those two. And the reason this turned into those numbers is because I just went too many decimals. I can move that. All right, so let's make this small again. This is kind of cool what I'm about to show you. And I kind of showed it to you a little bit up top. I'm going to take these two and I'm just going to stick them over here. And now, oh, did not mean to do that. I just want some more decimal values here. All right, so I need to get to 37, right? And 37 is somewhere 0.37%. And the reason that moved is because those are no longer in percent. So I need to put them in percents. So 0.37% is somewhere in between there. So I'm going to change this to 451. Select these two. And look, I found it. It's somewhere between 459 and 460. Do you guys see that? And I really am trying to get to that 37%. I hope you guys see what I'm doing because it's pretty cool. So we have 459, I don't know, 0.1. How about that? 459.1. And then I'm going to get more decimal points here and less decimal points over here. All right, so select these. And now I can get even deeper and see that it's somewhere between 459.4 and 459.5. And you guys can keep doing that. You can also solve this using logarithms where you would divide both sides by your initial starting amount, add the log to both sides, and perform the algebra. And you can see how to do that on your example for number 40, and that's what you will have to do on your homework. You can use this method on your homework also. If the algebra just really scares you, you can totally use this method. I think it's amazing and cool how we can just keep zooming in on those areas. It's kind of like Excel is the microscope to algebra and we can replace algebra. All right, so let's keep rolling here. I want to now create a graph. So I'm just going to select this, insert a chart. And of course, I want you guys to name your chart. And then of course, I want you to insert a insert a text box to discuss your scenario here. All right, label everything. Make it colorful, make it pretty, make it yours. Take pride in your work. Guys, that's your Excel report for Module 4. Just one more module, and this semester is over, and you guys have your college level math credit. Yay! Keep being amazing. You rock. You.